Everyone, and welcome back. We're going to continue on with our discussions for our introduction to Python. So let me go ahead and share my screen, and you can feel free to follow along, or you can just watch the video as you like. All right, so we have been talking about how to work with Python, how to acquire Python, and we have taken a look at how to write some scripts, working in the scripts versus working in the interactive interpreters. So that's all terrific. But of course, one of the things we want to understand is how do programs actually work? How does it get from the thing that you type to actually running on your computer? And so we're going to answer some of these questions today and into our next lecture in terms of how programs are categorized, what the different kinds of programming languages are, and a little bit about how your computer works. So we're going to pick up now talking about the computer hardware. That is the actual physical pieces of your computer. And so computers are going to have a number of pieces in common. Of course, you're probably already familiar with the keyboard and the screen and the mouse and these kinds of things. We're going to talk a little bit more about what's actually inside the box and try to understand how that works with the program that you write to actually make things work. So one of the most important components of your computer is called the central processing unit, or the CPU. And here we have some images of what a CPU looks like. Here is an Intel Xeon 5600 right here. This is the top of it, and it's actually plugged onto a board. And here's the bottom side. So if you were to unplug it and you would look at it, all of these are little teeny pins that are plugging in to this circuit board here. And here we have an image of an Intel chip actually plugged onto a motherboard. So we'll see what the motherboard is in a moment, but it's basically the the main circuit board of your computer. This is the Intel Core i5-13600K. This is one of the most powerful CPUs that's currently available today, and this is what it looks like. Just to give you a sense of scale, this is like the size of a screw right here. I'm not sure if that is a screw, but that gives you a sense that a computer chip is about maybe like 1.5 inches by 1.5 inches or so. It's probably like 1.5 inch by 1 inch. So it would like smaller than the credit card size, relatively small, a little bit thicker than that. And that's what it looks like. It's often referred to as the brain of the computer because this is the thing that actually does all the calculations. And so somehow when you write your program in Python, it's got to get from your idle interpreter somehow over into this chip to actually do the calculation. This is what's responsible for executing all of the instructions and performing all the calculations. It also makes your computer actually run. So it runs your operating system, which means like your Windows or your Mac or your Chromebook or whatever operating system you are running. All the processes that are involved in that are going to go through this processor here. It interprets and carries out the instructions provided by the computer programs, making it a crucial component for overall system performance. And so it largely is what will be responsible for how fast your computer will be able to run. So we also have another important part of the computer, and that's called the random access memory, or RAM. And it is a memory thing. And sometimes when we think about memory, we think about storage disks. Maybe you're familiar with like USB drives or other kinds of disks. Maybe you work with some disks and this kind of thing. This is distinct from that. The RAM is actually a really special kind of memory, and also it doesn't really look too much like a regular disk, at least the part that you would see. Here we have some disks actually plugged in. So these are several memory cards right in here, and here we actually see someone plugging in a RAM card, so we call it the RAM card, into the motherboards. This is the main circuit board of the computer, and there are some little clips over here, and you actually can buy this unit, and then you pop it in and see how there are these little gold colored things down here. These are actually the circuitry, and it's connecting with all of the little connection points inside this slot here. And so you can actually plug multiple in, which is what's being shown up here. And so that's what the RAM would look like. So why is the RAM so special, and how does it differ from just like regular memory that you'd buy like on a disk or, you know, that kind of thing? The reason is because this is the only memory that the CPU, the central processing unit, is able to actually read off of. It needs to read a special kind of memory because it needs to be able to read it very quickly, and it needs to be directly connected to it. And so when a computer program is actually executed, the CPU is relying on all the information to be written in here. So what has to happen is there has to be copying from the other disks, like the normal disks, like the hard disk on your computer, or whatever's in your program. The information, the data, the instructions, and so on need to be copied into the RAM. And then the problem happens when your RAM gets full. So this is memory cards. RAM memory cards are very expensive, so they tend to be much smaller in their capacity than other kinds of storage disks, like the disk where you would be like storing your homework, for example, which is a more persistent kind of a memory. And so in the RAM, what you need to do is you need to copy information in, and then it gets moved out and copied over with the next piece of information that's needed. And that's maybe going on as your program is executing. So oftentimes the RAM is going to be able to speed up your computer, because if you have more space to write things before you need to erase and copy more stuff in, then it will run faster because you're not going to have that problem. So it's a type of volatile memory, and what we mean by that is that you're not going to be saving your permanent homework files. Like, you're not going to be able to save your Python files to your RAM. Volatile memory means that this is something that's going to be written to transiently while the program is running, and it stores data and program instructions temporarily while the computer is running. It allows the CPU to quickly access and manipulate the data, enabling multitasking and efficient program execution. If you were to attempt to use something besides the RAM, not that this is even possible under normal circumstances, but let's imagine you're going to try to run it off of, like, you know, your USB port on some memory disk. The problem would be that it would be very slow, and your program would be exceedingly slow. And so this is how modern computers are made. They're made to read and write off of the RAM for the part that's actually executing. And so when we say to add memory to a computer, we're really talking about adding these RAM cards, which are these chips here with these the microchips on them that plug into these slots on the motherboard. And that's what we're talking about when we're saying adding RAM to your computer. There are also the regular computer disks. There are actually, so this is the kind of a disk that's on your computer where you're actually storing things. So for example, if you do file save as and you're selecting something like my documents and so on, you're gonna store it here. Now, the cloud has kind of changed that a little bit if you have cloud map devices, because it may actually not be saving it on your hard disk, but traditionally that's how it works. And oftentimes when you have things on the cloud, there's also a local copy on your hard disk. And when you download something, for example, from the web, or you've saved some pictures, or you save some music onto your computer, it's going to be storing onto these disks. This is actually what a disk looks like. It comes in usually in this kind of like a metallic sort of a thing, and there are some prongs here, and you can plug this into your computer. So if you're working on a laptop, for example, you will have a hard disk, and it would be located underneath the keyboard in that section there, along with your motherboard. And so this is just a diagram of that being pulled apart, and it's showing you the various parts of your disk. So maybe you've had a look at the CD. I know they're getting to be a little bit old technology already. But a CD works as an optical drive. These usually are working as a magnetic drive, but similar to an optical drive, these need to spin. And if you're starting up your disk, you may actually be able to hear it. And what you're hearing is that this disk is spinning around. And this is the read-write head, which is going in and it's sensing the data that's being stored here. So typically this is going to be a magnetic situation where something is magnetized either in one position or another. This is called the arm, and then this is the actuator. And here we can actually write some files onto the disk, and of course these are the disks. So there, and this is the spindle, which is in the middle that holds the disks. And we see that there are multiple plates here and multiple read-write heads. And so there's just multiple copies of these inside, and that is all in here. Now, this here is actually the part that plugs in, and you can see that there's some stuff down here that is diagramming this out for you. So there will be the power ports. This is how electricity goes in, because this is when this plugs into your computer, then this gets the power. Here's the data cable port, which is going to connect with the data. Now again, notice that the connectivity tends to be with these pins, so they're like kind of flat and flush onto this. And in most cases, sometimes there's like some pins that stick off and there's a little bit of space, but it doesn't look like, you know, a big plug that you would plug into the wall. This is relatively small. And then there's also the drive configuration port, which is over here. And here's the circuit board that is going to be having the circuitry in order to actually do the logic and run this disk. So that's what this looks like. So this is the hard disk drive, or HDD. HDD is one of two storage devices used to store on the computer's operating system, programs, and data permanently. That doesn't mean you can't read and write it. But what we mean is that when the computer is turned off, the data is still there. So when you save your homework and then you close down your computer and you start it up the next day, it's still stored on your computer. Whereas in the RAM, it's gone. HDDs use the magnetic disks, and that's what we were looking at here. It provides long-term storage even when the computer is powered off. And that is the great thing about the disks. But there's also other kinds of disks, and these are the solid state drive disks, also known as SSD. This is a bit of a newer technology. And just like the HDD, the SSD also is used for long-term persistent storage of computer files and information. The SSD, however, stores information instead using flash technology, which doesn't require any moving parts. And so this is the same technology that you would use to write onto a USB drive, for example. And flash technology has really fast read and write. The downside to this is that there is a limitation as to how many times you can read and write, but the number of times is very large, probably larger than what you would be actually using your computer for. So we usually don't worry about solid state drives failing for that reason, although if you plan to use your computer for, say, like 20 years, which is a very long time to use the same computer, you could exceed the lifetime of your solid state drive. But what you get in exchange for that is to be able to store information for a long period of time. And the SSDs do tend to be really fast. They also have no moving parts. So one might say that these disks might be more robust than other disks because the moving parts could potentially break, or if you put on the floor, you could imagine that those fragile heads would break, that the disks would crack, and many other problems that one could have in everyday life, which is why we should always have backup copies of all of our work. There's also a graphics processing unit, or GPU. You might have heard of these. This is some of the newest technology. Not all computers are going to have this. It is possible to have a GPU in your laptop, although not all of them do. This is typically for higher end computing resources. The graphic processing unit actually was developed in the context of gaming machines, and here's a nice gaming machine over here being depicted. As it turns out, though, the technology has actually been really quite useful for many other sectors, and as a matter of fact, we use gaming machines in my research lab because they run really fast to run molecular dynamics calculations when we have a computer much like this one. And if you peek in the background of some of my videos taken in the office, you may actually spot some of our machines running in the background. The GPU is also known as the graphics card, is responsible for rendering images, videos, and animations. It offloads graphical processing tasks from the CPU, making it essential for smooth graphics intensive applications like video games, multimedia, and high performance computing. So this is why I particularly am interested in it. So this is your graphics card. It's right here. NVIDIA is probably one of the premier makers of graphics cards, although there are others out there. And so you can see that it's this unit right here, and here it is plugged into the motherboard, just like some of the other discs that actually plugs in. So there's multiple bays over here, and not all of them are full. This one just has one graphics card in it, but it appears this particular machine would be able to have a couple, and you can see that some of the cables are being plugged into the side here. Some of the interesting things about these are that they actually are a little different than some of the other discs. So for example, when discs are operating, they generate heat, and it's important that you remove that heat. That's why gaming machines have so many fans. So these circle things have lights in them, which so they look nice and flashy and so on. But the real reason why these things are here is because these are the fans, and they're just spinning really fast, so you can't actually see the blades. But these have their own fans, and then this is the fan. You can see it a little bit right here. And there's also surely a fan on this GeForce RTX. It's probably right underneath here. And so then what you are trying to do in your box here is to make the fans go to remove the heat so that the machine is cooled and it doesn't overheat. So if you ever heard of a meltdown, literally what that means is that the components in the computer heated up so much that they actually melted the plastic. So don't forget there are plastic components in here, and you can actually melt them. And also the solder, it's possible to melt, although I think you'd have to get really hot to melt the solder. But these things do throw quite a bit of heat, and so that's why they look the way they do, and why these graphics cards have the fans in them. The way that they work is they actually try to improve the the way that the processing happens. So as we mentioned in this text here, it's offloading work from the CPU. So we said before that the CPU does all of the operations. That's mostly true, but if you have a GPU, some of the operations that can be put into matrices, that is arranging the data in rows and columns, GPUs are really great at working with them. And so what they can do is they can load the information onto the it can be loaded all at once, and then it can be processed in a systematic way, and things can be accessed using a grid rather, because you have a row and a column. So you could set up an X and a Y coordinate to access your data, and you could just have it all in a row or in a column in some kind of a predictable way, so that the loading in and processing of the data can be really quick. So anything that could be represented as that, such as the pixels of an image, which could be really represented as X and Y coordinates with a teeny tiny dot, right, with a color in it. That's how pictures get generated. That's why they're so good at generating images on the screen, because basically it handles simply just displaying colors in one pixel is an array of X and Y coordinates. And so anything else like data, such as for molecular dynamic simulations, which is what I use my GPUs for, well, do you think that the GPU really cares whether it represents a picture or if it represents a molecule? The computer graphics card doesn't know the difference. So even though technically that's not graphics, it would happily run those calculations really fast. And that's why we use them. And we've mentioned the motherboard a couple of times. The motherboard is the main circuit board that connects and holds together the various components on the computer. So here you see this is just a very large circuit board, and all of the things have been stripped off of this. So you see there's a place here in order to plug in a CPU. So there's a couple of slots for CPUs these days. Why limit yourself to one CPU? You could have multiple. And these also here are the RAM slots. So we see that there have been no RAM cards put in. So what one would do is purchase the RAM cards and then install those here. These here are for cooling. And I don't see a GPU slot on this particular board. But anyways, this gives you a sense of what that would look like. This board is probably, you know, maybe a little more than a 1 by 1 square foot here. This is probably, you know, about the footprint size of a laptop or desktop machine. It's sizable as far as computer components go. It provides communication pathways and power connections, allowing the CPU, RAM, GPU, and all the other peripherals to work together. So there are places for everything to be plugged into. You'll see here your network, plug in for your Ethernet cables. The power supply needs to go into here. So basically all of the things that need to run on the computer all need to be plugged into the motherboard, and that they are going to be talking by being connected to this. Here's a labeled motherboard. This is a slightly different picture, and you can see that there's a number of items here that that you would need to put onto the motherboard in order to make it work. So here we talked about the RAM slot. This is the CPU socket. So you would plug your CPU in here. Those are all the little holes for each of the little pins. This is a condenser. This is a parallel ports. This is probably a bit of an older machine. You can plug in the monitor here. This is a mouse port. This is a keyboard port. These are some of the very older plug types. Here's a USB port, which you're probably familiar with. So you can plug in USB devices, so keyboards, mouse, that sort of thing. COM port is, again, is for input and output VGA. This is for video. This is an audio port. They call this the game port, I guess, for audio for games. There are some, well, you may have the HDMI cable these days, which is more likely what you would be using today, but these ports do exist. Here, this is for the BIOS and the ROM. This is what turns your computer on and gets it started before your operating system runs. Here is your heatsink and fan connector. This is where you would plug in your power supply. We haven't really talked about these things too much. Some kinds of battery backup and so on. It's the helping processor here, and then you could have some various chips on your computer. Just gives you a sense of what kinds of things could be on a motherboard. So I do want to talk to you a little bit about some of the various kinds of programming languages, and we are also going to talk about how we actually go from your actual programming language to actually running on the computer. So we're gonna pick up with that in our next meeting. So thanks so much for joining us. Hope you found this helpful, and we will talk to you next time. Bye-bye.